Okay, so this is your third lab. In this lab, we are going to discuss about exploratory data analysis. Now, this is actually the starting part of your training a machine learning model. You have to do whenever you work with a data. This is the first thing that you need to do to understand what that data actually represent. Okay. So there are two lab manuals created. One is for this one. This is for one data set, and this is the another one. Okay. So you can find all these things in the GitHub folder. So I ask you to open your Google Chrome, open your Jupyter Notebook or your Colab, and open the notebooks there. I'll give you some tasks to do in the meantime. Okay. Acha. So you can, everything is written here so that you can actually understand everything properly. Let me actually elaborate. So when you actually start with the data, you need to understand what that data represent, how are different variables, how many rows or how many sample points are there, what are the relations between the variables. And also raw data, that is the real world data sets, actually have some issues. Sometimes the data is missing. So some variables are missing, some variables are not actually proper. Need to remove some of the variables we might have to. So we'll see gradually one by one. There is a entire there are lots of things that need to be considered in exploratory data analysis. So the more you practice, the more data set you actually practice, the more and more thing we'll actually learn. So let's start with this one. This is the tightening data set. It's a very common thing, a very common data set. Now, you can find the data set in the Kaggle. So to work in the tightening data set in the Jupyter Notebook, first you have to download it in the same location, or in the Colab, you can upload it. Okay, so the tightening data set contains the records of like the voice, in the voice, how many people actually died and survived, the records of those passengers. Okay, and some information are also there. So we want to know, let's say, for instance, we want to know what are the relations between the variables, like uh, based on gender. So how many percentage of men or how many percentage of female survived or not? Okay. So what is the chance of a particular class, let's say one first class, second class, third class passengers to survive? These are lots of different questions that will appear. We'll gradually try to look into those things. Achha. So let's see, this is our workflow. This is the common workflow that we actually want to proceed with in EDA. First, import the libraries, then import the data, then analyze the data, then finding issues in the data, then visualize. Sometimes you can have some inquiry questions that you want to ask. So we'll gradually look into those things one by one. Achha. Let me come here. Yes. So before I start, do you have any question? Anyone have any question? Anyone have any question? Achha. So EDA now, first part is importing the libraries. And when you do this kind of thing, this kind of EDA, you need to write in a notebook, just like I showed you, details. Everything should be detailed. You can put a comment there. You can actually create different sections there so that it is very easy to understand what you are actually doing. It is not just you understanding what the people are that are reading your notebook, they can also understand. So you should actually make things in a more organized way. Okay. So similarly, when you submit your lab assignment, especially the project, you should make everything much more organized. Okay. So import the libraries. So you know some of the common libraries that we need, like we need pandas library. So you know how to import these libraries. You already know these things in lab 1 and lab 2. We are going to need all of those things, all of those skills in here. So you import pandas library, you import numpy library. We need pyplot, matplotlib library, as well as c1 and scikit-learn. We need a little bit of scikit-learn here today. Okay, so we'll start looking into scikit-learn today. So I think this 5 will be enough for now. Achha. So once you are done, after that, we want to import the data. So you keep it like a section. If you look at here, we start with some introduction to the dataset. Also, the link to the dataset is also given, workflow, and importing libraries. So if you have if you have to create multiple cells, then you can actually create it in a different cell, but put everything in the same place so that everyone can actually understand very clearly. Acha. So there are two files there in the Titanic dataset when you are going to import data. One is Titanic train, Titanic test. So sometimes, so data. So to import the data, we have the library, we have the function pandas dot read CSV. This is for CSV file import. That is the most common file. You can also work with Excel file. You will find. So that is for read Excel. Pandas dot read Excel. Okay. There can also be text file. Okay, there are different formats, file formats. You can check whenever you actually deal with a file format, just check it. What is the relevant function there? So inside the bracket, read CSV, you just have to put the name of the CSV file. So in this case, we have, let's say, Titanic train, or let's say Titanic.csv. So, and it will be imported in your data frame. You have to give it a variable name. Achha. Now, the data can actually come in two sides, in two ways. One is entire data that we'll find later, or it can be split into train and test. Achha. Now, training and testing is something that we do when you actually start in a machine learning pipeline. And so after we process the data, we actually divide the data into training and testing for some reasons. If you have studied machine learning in the class, you already know those things. But for now, just we'll mostly work with the training set. And if your data is not divided, you will work with the entire data. Okay. So for this scenario, the Titan dataset is already divided into train and test. So we'll work with the train data post and see where we need the test data. So this is the import data portion. Okay. Achha. Now, if we look into the data, now when you view this data, you just call train df, you can view this data and you can see different variables are there. Okay. For instance, this is the passenger ID. So you can ask this question, what does this survive? Survive means whether a person survived or not, passenger. So 0 means the passenger did not survive. 1 means the passenger survived. So P class. So 3, 1. So you can ask this question, what does it mean by 3 or what does it mean by 1? So whenever you work with a data set, you should look into the source file where the file is actually taken from. And in the source file, it should be clearly mentioned what each feature variable represent. So if you go to this directory given here, so in the Kaggle directory, you will find there actually what are those things. So let's go, let's see. Yeah. So you can see it is mentioned here what are the feature variables represent. So P class means the ticket class. So it's like first class ticket, second class ticket, third class tickets. It's like this. So then we have the sex variable, age variable, CBSP. So if you look at CBSP, you will not understand what does it mean. So we have to look into the directory, original directory where the dataset taken. So they actually mention everything clearly so that you can actually have some understanding what this data actually represent. So whenever you work for a new data set, especially when you try to build a machine learning model, first try to make yourself familiar what this data represent. It is very important. So let's see. Let's go back. Where we are. So you can see P class, this is the passenger class, then you have name, then male or female, then the age, CBSP. So this is sibling and spouse, the number of sibling or spouse the person has. PRCs, that is parents and children. Then this is the ticket number, then this is the fare, this is the cabin number. Okay, so you can see the dataset has 891 rows and 12 columns. That means the dataset contains the record of 891 passengers. Okay, and there are 12 feature variables are here. So if you look at the test data and this head function, head or tail, there are two functions. When you want to look into the dataset, you may not want to view the entire dataset. So you can actually use this function head. So your data frame.head, it will by default show you the top 5 rows, first 5 rows. There is also df.tail. if you write inside the bracket, if you write 10, it is going to show you the last 10 rows. So this way you can actually view as much as you want to view. There are two different functions. Achha. So you can see in the test data set, there is one feature variable missing, that is the survive class. So that feature variable is not there. So you only know the survive variable information for the train set. For the testing set, it is not given because you want to test it on unknown data. That's why it is not given here. So we'll look into those in the lab for when you actually go for predictive modeling. For now, let's just try to understand exploratory data analysis. Achha. So in the first step, what you want to do, we want to understand what these feature variables means and what is actually the target variable, what you want to do. So if your task, for instance, let's see, number 3, task. So in EDA, your task can be different. For instance, do you want to perform just simple analysis or inquiry? For instance, in your this week's assignment that is provided to you, you will find a data set that is police shootings. Police shootings data in the USA. So yeah, not just police shooting, fatal police shooting, the people when people are shot dead. So this is a data set actually curated by Washington Post. Now, in that task, you are not asked to perform any predictive modeling. You just asked to inquiry about the data set. What are those data sets actually represent? So how many people actually died? Okay. So what are the yearly distribution? Where the exact locations where the people actually died? So in different states, how the number varies? What is the age group? If you try to plot a histogram of age, you will find that there are some people as small as 4, age 4, they are also shot to death. So there are some specific reasons. You can look into those things. So this is analysis type. You want to analyze the data, perform some inquiries to get some better idea of what is actually happening inside. So this can be one task. Another task is for number 3. Another task is for predictive modeling. Okay. So when your goal is predictive modeling, you need to, in this case, you have to prepare your data for predictive modeling. In analysis, you have to do some pre-processing to understand, but you don't need to prepare your data. For predictive modeling, you need to prepare your data. So you have to understand what is your features and what is your outcome or target. So target means what you want to predict. So target means this is what you want to predict. And based on this feature, these attributes, we want to predict that. So in this case, for instance, Titanic, we are actually looking at this one. Okay. For Titanic, we're into looking at this one. We want to perform predictive modeling. In the lab 4, in the next lab, you will perform predictive modeling on that data set. So for today's lab, we want to perform the analysis, EDA for now. Achha. So if you look at this data set, what do you want to predict? We want to predict this particular one, survive. Okay. Based on the other feature information that we have, we want to predict what is the chance of a person to survive or not. That is what we want to do. Okay, that is our ultimate goal. Is it clear?
Yes, sir.
Yes, sir.
Achha. So let's see if we want to do it. So this is our target variable. So all the others are feature variables. So let's see if you want to get the column names. 3. So this is your task. 4. Analyze. Let's perform some analysis into the feature. Understand the features. So, for instance, if I want to know the column names, you have the data frame dot columns. Okay. So, if you are in your, those of you who are in your Jupyter notebook, if you write df.columns, see how the outcome variable looks like. What is the data type of the outcome output? df.columns, and let me know in the comment section. Okay. Quickly.
Sir, object data type.
So this one, .df.columns, is going to return you with a object data type. Achha. but we actually want them. So this is a data frame object, but we don't want it this way. We want it as a list. I want the exact column names. So what you can do, there are two things. One you can do, you can just write list, then inside the bracket, you can do it like this way. This is going to convert this one into a list. Check whether it works or not. করতেছে? আসে? আর কেউ করতেছে না? লাস্ট ক্লাস, কিন্তু তার মানে এই না যে তোমরা এখন বসে বসে ঘুমাবা।
Yes, sir, it works.
So there is another way that you can do. If you do it like this way, tf.columns dot values. Now what is the data type of the output?
Object.
tf.columns dot values object আসে?
Object data type.
অবজেক্ট আসার কথা না?
স্যার অ্যারে
Array
ডেটা
আসে।
টাইপ অবজেক্ট বাট অ্যারে হিসেবে আসতেছে।
এটা এটা হচ্ছে আচ্ছা ভিতরে অবজেক্ট। দিস ইজ অ্যান অ্যারে, দিস ইজ দ্য আউটপুট ভেরিয়েবল, দিস ইজ দ্য আউটপুট, আউটপুট হচ্ছে অ্যারে। সো দিস ইজ এ নামপাই অ্যারে। ওকে, দ্য আউটপুট ইজ এ নামপাই অ্যারে। So you can, if you want it in a numpy array, you can use this one, or you can actually convert it into a list, whatever you want to do. So this is your column names. You will later, you will need those things later. Acha. So this is the column value. So if you look into the columns, okay, so you can understand these things. So these are your column names. Now, let's see the data types. If you look at the data types of the columns, there is this function d types. So 10df and d types. Acha. So d types, now you say there is no bracket here. We did not use any bracket. আমরা কি ব্র্যাকেট ইউজ করছিলাম? After
না
values, I
স্যার।
will not use this one because this is a attribute, not a method. এটা নিয়ে একটা কোশ্চেন ছিল তোমাদের কুইজে। When it is an attribute, you don't use bracket. When it is a method, when you call a method, then you have to place a bracket after this. And if there is if there is an internal parameter, you have to put it inside. So that's the question. So now you can see most of them are integer 64. There are few objects. Object means like name. This is a string object. So then you have some floating point values. Also, their age is in the floating point. Acha. So we'll need this kind of information later gradually. Acha. Now we want to ask this question. We will need it. For instance, what are the categorical data type feature? Categorical means different categories are there. So for instance, whether the person survived or not, 0, 1, 2 category. Then whether he is a male or female, 2 category. Embark means where the person actually started their journey. And if you look into the data set, কিছু না সেটাই হোক, দেখা যাচ্ছে না embark ফিচার আছে। আচ্ছা, so you can see here QS, then C. If you look into the description of the data set, you will find Q means Queensland, I think. Okay. Where the person started their journey. So there are 3 places where the person actually started their journey. So based on this, you have this feature variable. So that is also another column. Another categorical value. Passenger class 0, 1, 2. Okay. This is also categorical, but it is in numeric. But in the other things, other variables here, you see here. So the sex variable, this is in male and female. Male, female, this is in string. But when it comes to machine learning or EDA, when you want to do those things, you need to convert everything to numerical values. Okay, that's why it is important. Anything that is categorical, but in the string, you have to, if you can, if it is a categorical in string, you can easily convert it into numerical values, because machine learning model will not be able to process your string value. Neural networks, that is actually NLP, natural language processing, there we can actually have some ways to process the string values. But for normal models that you have in machine learning, we need to convert everything into numerical values. Acha. So we have to convert this one, and then also embark. This is also string. So we need to convert these values. But see, this name value, this is just a name, like unique name, most likely, in most cases. So do we need to convert it into number?
No.
Uh, because name is just a name. It does not actually provide any information for analysis. Like if I want to know the different distribution of the data set, it does not provide any information. So that is not irrelevant to our analysis. Similarly, passenger ID. This is just an ID assigned to each of the passengers. So it does not matter to us. So we can actually remove those values as well. If we keep those values, if you keep this kind of irrelevant values there for machine learning model, your machine learning model is going to add some bias to it. It is not going to perform well. So you have to remove those things. So you have to identify those things very carefully. What are the features that are important, what are not? We'll gradually look into that. So this is what you start doing. Okay. So numerical value, again, let's come here. We have seen the categorical values, numerical value. Age is a numerical value. Fare, what was the cost? Okay. That was also numerical. And discrete, this is sibling numbers and parents, child, children number. That is actually numerical value. So we don't have to worry about that. Now, if you want to know the like distribution of each of those things, so you can use this function value count. I think this is also in your quiz. Any column that you want to know, let's say I want to know which column chilo, 6 dot. You have this function value counts, and this is a method. So now I'm going to put a bracket there. Okay, so value counts. Now I'm going to put a bracket there. It is going to show you how many passengers are male and how many passengers are female. This is for your categorical feature. So that's why we looked into this, which are the features that were categorical. And those categorical features or categorical okay, features, we can actually have this kind of information there. You can also put it into a bar plot. You can just put a bar plot simply here using this one. So you can see there are 577 passengers that are male and 314 that are actually female. So there is almost half. There is a distribution difference here. Also, sibling numbers. You can see 0, sibling and spouse. Without any sibling and spouse, there was 0. There are 608 passengers. So most of them are without any siblings or passengers, so traveling alone. But many of them are traveling with many siblings and passengers, you can see. Similarly, this way you can actually look into the variable to understand what is the distribution of the data. Okay. Achha. So passenger class, you can see third class. So in the third class, there are most number of passengers, 491. In the first class, there are 216. And the second class, there are even the lower, 184. Later, you can actually ask this. So after this, you can actually inquire this question. Okay, what is the chance? What percentage of the population that belong to, let's say, this third class survived this journey, or in the first class? Okay, so this kind of inquiry is there that you want to answer, and that's where your some analysis actually is going to come later. Okay, so then again, inversion, port of inversion, you have Queenstown, you have Southampton. Achha. And survive column, you can see 549 passengers did not survive. 0 means did not survive. 1 means survive. 342. So almost not twice, almost 1.5. Achha, so this is your what your data actually looks like. Okay. Is it okay? Is it any question about the data? Any question about the data? কারো কোনো ইনকোয়ারি আছে?
No, sir.
Okay. Acha. So once you actually have viewed the data, so this is how you actually should proceed when you start working with the data. So that's something you need to understand. So this is you start. You start with each and every variable, each and every feature variable, and gradually see what those features represent. Acha. Then you start asking the questions. Questions like, okay, is this feature relevant to my task? Or what does this, what kind of knowledge can I extract from this feature? Also, whether this feature actually has some issues there. Okay. Is there any null value? So this kind of question you start asking. So after you have viewed this, so this is the analyze the feature. After you have viewed those features, then go to processing part. You look into the processing part and you ask the questions like relevancy. Is that feature variable relevant to us? Number two, is there any missing values there? There are many things that will come. I'm going to name a few for now. Then you also want to know the correlation. correlation within the feature values as well as the feature value with the target value. So you can understand which feature are highly correlated to the prediction of the outcome. So relevancy, missing values, correlation. So these kind of questions that you understand. And just by viewing in the previous step, you already know that ID is not relevant to us. Okay. Then also the name, this is not relevant to us, right? This is already you have found. Achha. Also, you have seen some missing values there, right? Previously, when we are viewing the data. See, there are some non-values are there. You have already seen. Is it slope? তোমরা কি slow পাচ্ছ?
No, sir.
আচ্ছা, ঠিক আছে, তাহলে ঠিক আছে। তাহলে আমার নেটে মনে হয় একটু স্লো আসতেছে। So you can see in the top right corner, non-values, non-values. There are several non-values there. That means that feature information is missing from the data set, and that happens a lot. So let's see what is. Then you should ask this question: how many feature values are missing? What kind of features are? Which features have some missing values there? So to do those things, we have to need some function. So if I want to do these things, so relevancy comes from analysis. Then missing values, there is a function that is called your data frame. Okay. And is now. This is a method. So I'm going to put a first bracket there. So if you call this function is null and see what is the output looks like. df dot your data frame dot is null.
The Boolean type, not the Boolean type, true, false. Like,
True, false. What is the size of the data set? Return. What is the size of the return value?
891 by 12.
Yeah, this is the whole data set, right? 891 by 12. So this is giving you a, it is checking each of the values in the data and showing you whether it is true or false. অন্যরা কি আর কেউ করতেছে নাকি জাস্ট
Whether it is null or not.
হ্যাঁ, whether it is null or null.
Yes, sir.
আচ্ছা, একটু পর আমি একটা টাস্ক দিব, তখন যখন হবে না তখন দেখুন নাম্বার কাটে দিব। আচ্ছা, so is null. So this actually shows you the overall idea, but we just want the summary. So what we can do, we can call this function like this way: df dot is null. Then in a bracket, you call another method. So this is like second degree method calling. So you call a method on the output. So this is your first method. On this method, you call another method that is sum. This is going to give you kilo. আচ্ছা, দাঁড়াও, আমার নেট চলে গেছে। Can you see the screen?
Yes, sir.
Achha. So if you call this sum, it is going to give you the summation of each column. Each column.
No.
Okay. Now, if you call this function and see what is the output now.
The number of null values in each column.
The number of null values on each column. So if you look at here, so now you can see in the train data set, you have 170 null values, each feature. On the Kevin, there are 687 null values. How many missing? Okay, out of 891, 687 are missing. And for the inbulk, there are only two missing. Similarly, for the test case, if you look at here, age you have missing. Kevin, there are 327, but here, fear is missing. Okay, previously on the training data, there was no fear missing, but in the test data, we have fear value missing. Achha. So you have seen this thing, so that your data actually has some like missing entries. Okay. That is one thing. Later, we will see how to actually handle those missing, how to deal with these missing entries. We'll look into it later in the later stage. So this is one issue. There can be other issues, like for instance, it can happen. We'll see later. There can be some Uh, typos means, for instance, so for in this case, let's say you have, if your data was written like this way, you have the column male and female string values. Acha. It can happen when the data was written. In one case, male was written like this way with a dot after male. Happened. Okay. In one data set. Then how many categories will be there? It will be detected as 3
3.
categories, right? But that is wrong. So you have to take care of these typos. So this is another issue that you actually find gradually when you actually work into many data sets. So just like relevancy missing values, you can also look, you have to also look into any typos or errors in the values. You try to view the data, overall data set, and try to understand those things. So it's more like a natural process. You cannot just look into it and find it. You will gradually have to understand. Acha. So let's move on. So you have seen the null value. Okay. You have seen the null value, and later we'll see how to do with those null values there. Acha. Then, so there is a function df.describe. This describe function gives you the overall distribution. And this is for numeric value, not for categorical value. So you can understand for age, the average age was 29.7. The minimum age was, I think there are something error is there probably. Sure, I have to take a look into those things, particular feature value. Okay, look into the feature value, age, and find the minimum age. Okay, you know how to do it. Find the minimum value of the age column. Just like your sum, you can find the minimum value or maximum value. Let me know what is the maximum or minimum value, and provide a screenshot in the comment section. Yeah, thank you, sir. Thank you. Just look at myself. ndf.age.mean, হ্যাঁ 0.42 এত কম কেন একটা? So this is something error is there, I think. In the data set, it should be numerical, like it should not be 0 point something or 0.42. Like the age is like 0 or 1. They probably actually add something 6 month old or 3 month old. They probably add that like this way, probably. Acha. So it can be there. So I think there was some child 3 month or 4 month old. They actually add it as 0.42. Acha, it can happen. It is not a wrong thing. Acha. Let's move on. So this is described. And if you want to look into the description of the categorical features, you can see here inside the describe function, you can use this one, include. Okay. This is one particular parameter. Now, to understand this thing, actually, you have to look into the, let me go there, show you here. So, So you just go df.describe. So this is your pandas data frame. Okay, df.describe. And I want to look into the documentation. So if we look into this documentation, so this is your pandas data frame. Can you see the screen?
Yes, sir.
Yes, Yes, sir. sir.
Okay, so whenever you are doing those things, and you just always remember, I'm showing you some of the functions, but you need to learn by yourself how to use this documentation. Okay, everything is there. So describe function, you can see percentage. What does it mean? The percentage to include in the output. Okay, so then include all a list. So everything is there. Try to understand each and everything. The description is very clear. Python documentation is one of the best. So everything what you want to know, you can actually find it here. You can see the function names as well as how to actually do those things. What are the inside functions? For instance, this is a one function. Pandas the data from for hire. Okay, this is like the find function that you had in MATLAB. So try to explore these things by yourself. Okay, and how to work into those things after you look into it, there is an example given here. So you can easily understand actually what does it mean. Okay, so try to use this documentation as much as you can and familiarize yourself. আমরা আমাদের কাজে চলে আসি শেয়ার দিস স্ক্রিন আচ্ছা সো আমরা কোথায় ছিলাম ওকে আমরা দেখতেছিলাম we are in the categorical features we are trying to view so here you can see this is your like this is the string features that you have so name was a string feature okay so you can see there are 891 unique values so when you have all the values unique it does not give you any statistical information so we should remove that feature okay that you already mentioned. For the sixth column, there are two. So that is something we want to need, and that is something we need. Then ticket. There are 681 unique values, right? So that means the ticket is actually like the ID. Does it convey any information to us? Does it convey anything?
No, sir.
No, sir.
So it doesn't really convey because it's just a ticket number. It can be anything. So it doesn't really convey any information. So this is one of the redundant features that we should actually exclude. Then you have the Kevin. There are 147 unique values and invert there are 3 acha so you can read through this description that I have written there so it will give you more idea. Let me move on. Acha so assumption based on the data analysis okay so when you have performed this kind of analysis you should come into a after you have viewed the data set you should come into some kind of assumption okay what we can do with the data set what can be some of the things then you test those inquiries that you have so correlation analysis, for instance, you want to know how the features are related. So, for instance, what is the chance a male passenger survived and what is the chance of a female passenger survived? So, you want to get this information. Or the passengers who actually embarked from S or Q, what is the chances of this relation that the passengers who embarked from S that they survive? Is there any relation there? So there shouldn't be any relation, right? A person embarked where the port of embarkation, it should not be anything related to the survival of the passengers. One thing that can be related, let's say male or female, there should be more chance of female passengers survive. So this is the intuition that you are understanding from the data set. Then you want to apply it, test it. So these are the inquiries that you should have inside your mind when you view the data set. Then you want to test it. So this is one thing. Then missing data handling. Okay, we are going to look into those things. Correcting. Some features may need correction. Some features we need to drop some of the features. Okay. So we'll look to and also last thing, creating. We can also create a new feature. Okay, sometimes it happens. This is called feature engineering, actually, this whole broad term, that sometimes the feature that you already have may not represent something properly. So we can actually create a new feature that conveys some better information than the feature you already have. So this is, we'll see one example here later. Acha. Any question up to now? Any question? Acha. So let's look into this part now. So these are the first thing that I said. We can have some inquiries. Let's come here. So we have seen some of these things, processing, then 5, 6, let's say. Inquiries that we want to answer. Okay. So to answer those inquiries, you can actually take into help of bar plot. or the function that we already use, value count. Achha. Now this value count was for univariate feature information. It only provides feature information of only one feature. So let's say what is the number of male and female. Okay, how many survived or did not survive, this kind of inquiries. But if you want group-wise information, like that actually takes two groups. So for instance, group-wise, so let's say your gender and survive. I want to know what is the percentage of male survive rate and female survive rate. So this is two variables involved. Okay. So in things like this one, you have to use something that is called a pivot table. Okay. It actually takes, you can actually get information of two variables using this pivot table. Acha. Any question so far? কারো কোনো কোশ্চেন আছে?
No, sir. স্যার পিভট টেবিলের ব্যাপারটা আরেক
হ্যাঁ আমি আসতেছি, আমি দেখাচ্ছি, ওটাই
একটু
দেখাচ্ছি।
বলুন।
আচ্ছা, so in pivot table what you do, two information, right? So I take my data frame, acha, and inside the data frame I want to call two features. If I want to call one features, I would just write 6. Okay, that's a one feature. It is probably the feature column name was 6. Acha. So but if I want two features, I have to put everything inside what? A list, right? I have to put a third bracket, double bracket. So don't forget these things. These were in your second lab. So so when group by using pivot table, I want two features. So you first extract that two features from the data set. And this is how you extract, right? Is it okay? Is it okay?
স্যার
Acha. After this one, you put a dot, then you call a method. Acha. The method is, let's say, group by. This is the function name. Okay. So group by means based on which feature you want to group it. Acha. So inside you have a parameter named by, and you just need to put the name of the feature. Let's say I want to group it by the gender category. Okay, so write this code, extract the two features, and on those two features, you try to group by them by this one feature value and see what is the output. Show me the output. আচ্ছা করো।
কোনো আউটপুট দেখায় না।
কিছু একটা লেখা আছে, what is written there.
Data frame group by object.
হ্যাঁ, it is
Pandas.
group by object, right? So the output of this one will be a group by object. And if I recall correctly, this group by object is a iterable. Acha. Acha. So this one, when you call this function, this creates a group by object, and it does not give you any information. Because it doesn't give you information, because you have something else you have to mention. After this one, you have to add a function, a method, that is what kind of information that you want. Information means, do you want the summation of, after you group by, let's say you group by male and female, ঠিক আছে আমি এটা করলাম, after you have grouped it by male and female, okay ঠিক আছে, then what is this information? Do you want the summation? Do you want the mean value, or do you want the maximum value? Things like that. What is the group by variable? So this is a group by variable. What is the group by method? What function that you want to perform? So if you look into the documentation, you will find different things, different functions that are can available. So for instance, for here, I want to get the summation. How many males survived? How many females survived? So after this one, I want to write sum. So first I extract those two features. Then I say that group it by this feature variable, then give me the summation and see what is the output now. Okay. Data frame dot group by, nine. DF dot group by.
So it gives a number of survived male and
Okay, so how many males survived?
male 109 and female 233.
হ্যাঁ, ওকে ওকে 109
33.
এত কম কেন? show me the show me the output.
So in
Sir,
chat box.
আসতেছে না। আসছে, হ্যাঁ আসছে। ওকে সার্ভাইভ, হ্যাঁ এখন ঠিক আছে, বুঝতে পারছি। সো ইউ সি হোয়েন ইট ইজ সার্ভাইভ 233 and 109, that is total hot how many? 200 342, right? 342 passengers had survive value of 1, right? ঠিক আছে না?
yes, sir.
Yes, so it is survive means it is actually taking the 1. Okay, so that's why it is showing you that female 233 passengers actually survived and 109 male passengers actually survived. Okay, so if you try to do it the opposite way, group by survived, and then you try to see, let's say, mean, try the mean value and see what is happened. Alter this group by, instead of using group by, you just use survived and see the summation or the percentage mean value, see what is the output.
স্যার এরর দেখায়, টাইপ এরর। আমি যদি মিন বের করতে চাই আর কি।
সাম দিয়ে দেখো,
Sir, male, 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 female, female.
দেখি দেখি কেমন আসতেছে।
হ্যাঁ, এরকমই আসতেছে।
আচ্ছা আচ্ছা, ওকে, হ্যাঁ এখানে একটু সমস্যা আছে। বলো কি সমস্যা, হোয়াট ইজ দ্য ইস্যু হেয়ার? বলো, হোয়াট ক্যান বি দ্য ইস্যু?
গ্রুপিংটা গ্রুপিংটা
হ্যাঁ, কেন হচ্ছে না?
হচ্ছে সার্ভাইভ হচ্ছে সাম করার কারণে না, গ্রুপিংটা সার্ভাইভ দিয়ে করা হচ্ছে, অর্থাৎ 0 and 1 দিয়ে গ্রুপিং করা হচ্ছে, and যেহেতু সাম ফাংশন ইউজ করা হচ্ছে, প্রত্যেকটা স্ট্রিং যেগুলো আছে সব
হ্যাঁ,
জাস্ট অ্যাপেন্ড করে
অ্যাড হয়ে যাচ্ছে।
দিচ্ছে।
সো ইউ সি when you put here this, instead of using survived, when you would put 6 there, that is a string variable, categorical string, and it cannot count it. Okay, that's why it is just going add these things one after another. We have to convert the variable into numerical, then you can actually count it. বোঝা যাচ্ছে আমার কথা? Are you guys getting me?
ইয়েস
So
স্যার।
when you group it by 6, that's fine because you have male and female there, and the variable that you are counting, that was the survived, this had 0 and 1 values, so that was very nice. But when you try to do it opposite way, when you try to do survived, it is 0 and 1, but now you have male and female, so this is a string value, they cannot actually process this string value, they cannot sum it or mean it, that's why you are getting the error. Okay, so we have to convert these feature values to actually get those information. So it is the next step we'll see. Acha. So let's see another example. For instance, passenger class and survived. I want to group by passenger class, then take the mean. Then you can actually have some, after this one, two, three methods, I can actually call another values, that is sort values. Okay, that is another method, sort values. This is going to sort the data frame that you are actually creating. Okay, then you can say based on which you want to sort it, or do you want to sort it in ascending order or descending order? These things you can actually mention. So if you look at here in your notebook, so this is where passenger class survived. Okay, survived, and we have grouped it by passenger class. Okay, we can see 1, 2, 3 passenger class, and the mean value we can see. So if you look into it, passenger class 1, the survival rate was 63%. Passenger class 2, 47%. Passenger class 3, 24%. So where Jack is from, so they have the lowest survival rate. So third class passengers, they are not allowed to actually go into the boat. Okay, so the first class passengers get into the boat. That's why they have higher survival rate. So you have seen the you know the issue. So this is how we actually try to understand the different distribution in the data. Then you can actually also sort the values based on which you want to sort by. So এখানে বাদ পড়ে গেছে, যাই হোক. So if you look into this sort values as a function, also as a internal parameters by, based on this you want to sort it. Okay, acha. So for instance, if you look at CSP, that is the sibling and spouse, there are too many values. You want to sort it based on your percentage. Then it looks very clear to you which one has the highest percentage. So this way you can actually do it by yourself. Acha, any question? So if you are looking at here, as index equals to false, see the difference here. When I use as index equals to false, that means I have, look at the second one. I have two features. The data frame has two features, P class and survive. So I didn't make the P class as an index. That's why it is, I have made it false. That means it is not an index anymore. But if you look in the previous one, here index is by default. So passenger class is now an index. So that's why it is in the lower side. Survived is now a feature or column. That's why it is in the top row. So passenger class has become an index here. So that's how you can actually change it, whichever you want. You can get it this way. So it's better to keep it this way, not using as index equals to false, that you can get the idea. Acha. Any question? কারো বুঝতে সমস্যা হলে বলো, কোনো সমস্যা নেই. আচ্ছা, let's see. Now, data visualization. So once you actually have this kind of information, you may also want to visualize the data. It also makes it easier for who is reading the reading your notebook. It makes it easier for them to understand. So you should use more visualization to make it much more clear. Okay. So there are some by default feature. This is actually from, if you're using Colab, you can get this kind of, automatically you can get this kind of visualization. আচ্ছা, ওগুলো আমার দরকার নাই. Acha. So you are already familiar with bar plot. Okay. So you already know how to create a histogram plot, how to create a bar plot. Acha. What is the difference between bar plot and histogram plot? বলো. বার প্লট কখন ইউজ করি আর হিস্টোগ্রাম কখন ইউজ করি?
স্যার হিস্টোগ্রাম প্লট ইউজ করে যখন আমরা একটা ডিস্ট্রিবিউশনের আন্ডারে ফালাইতে চাই, লাইক নর্মাল ডিস্ট্রিবিউশন।
হুম, আর বার
আর
প্লট?
বার প্লট হচ্ছে জাস্ট আই জাস্ট ওয়ান্ট টু সি যে কয়টা ইন্ডেক্সের আন্ডারে কি কি ভ্যালু আছে, লাইক সার্ভাইভড এর 0 এর আন্ডারে কয়জন প্যাসেঞ্জার, 1 এর আন্ডারে কয়জন প্যাসেঞ্জার আছে, এরকম আর
That's the categorical, right? When the information is categorical,
ইয়েস
then we want to go
স্যার।
for bar plot. Acha. So there is one other new figure is given here, that is, acha, this is histogram. Later we see. Acha, let's start with this one. You can see the age-wise distribution here for histogram. And if you look at here, survive 0 means passenger did not survive. And you can see there are more passengers did not survive. So this histogram actually has more data here. And survived is the people who actually survived. And you can see there is a higher number of people with very small age, 0. So the children's, okay, the infants, they actually survive. There is a higher number of people who survive. And also there is a passenger of age 80. Yes. Any question? Acha. So if you look at here, for instance, 80, around 80, there is a value here. So that means a passenger with age 80 actually survived. So when you view this data set, when you visualize the data set, this kind of things actually take your notice. So you can see some of the infant, the children, and the highest passengers, they actually survived. Middle-aged passenger did not survive. That is most of the passengers did not survive are from the middle age. Acha. Galo. Now this is for your like two variables together. What if I want to add more variables? Okay, and you can see these are the observation, these are the decision. This is for you to read. After you are done with this lab, you will read this data, read this notebook top to bottom. Okay, clearly. Acha. If I want more information to it, okay, multiple information, then we actually need this kind of facet grid. Acha. So this kind of grid. Okay. So you can see I want this survive, but also passenger class. So I have three features now. So this is 3D information, 3 dimension. So for two features, I can do those things, but for three features, I have to have this feature, this kind of facet grid. So on the x-axis, you have age, and in the third axis, you have the survive 0 and 1. And here you can see, sorry, in the second axis, y-axis, you have the survive, and the third axis, you have the passenger class. So the top row is for passenger class, and this is defined as row. You can see here in the row parameter, you have passenger class. So this is your first row, passenger class 1, second row, passenger class 2, third row, passenger class 3. And if you look at the survive 0, you can see from the third row, passenger class 3 has more higher rate of not surviving. Okay, where passenger class 1 and 2 has a better chance of surviving. Okay. Also, in the passenger class 3, many children, that is almost 10, 11, more than 10, at the range of less than 5 years old, they did not survive from the passenger class 3. But there is no such passenger exist in passenger class 2, but there is one from passenger class 1. So this kind of information, variable information relating 2 or 3 features, you can actually represent those things using this kind of figures. Okay. Any question? তার কোনো question? তোমরা যখন বাসায় বসে দেখবে ভালো মতো দেখলে আস্তে আস্তে বুঝতে পারবে, এবং when you do it, try to get some other features also and see what is the relation distribution there. Okay, extract those information. Acha, this is another example for invert. Okay, now let's move into feature engineering part. Acha. So we actually saw some of the issues in the data set, and we want to now tackle those issues. The first thing was we had found some irrelevant features. Okay, so for instance, irrelevant features if we go, yeah, previously we have previously seen ID and name. These two features we did not want, and later from another analysis we have found a third feature, that is the ticket, right? These three are completely irrelevant because this does not actually contain any information, redundant. So you want to drop the features. Okay, so if I want to drop features, so you have this function, right? df.drop.
স্যার
Yes, বলো।
স্যার একটা কোশ্চেন ছিল যে ক্যাটাগরিক্যাল ক্যাটাগরিক্যাল নিউমেরিক্যাল ফিচার এটার প্লটটাতে মাঝখানের দাগগুলোকে কিছু মিন করে?
কোনটা? ও আচ্ছা, এই যে এই ডাকটা, এই যে ইমবাক্টে।
জি স্যার।
আচ্ছা, এটা হচ্ছে এটা রিমুভও করা যায়। এটা হচ্ছে বার প্লটে অটোমেটিকলি চলে আসে। এটার একটা স্পেসিফিক রিজন আছে, সেটা আমি আরেকটা ক্লাসে ডিসকাস করবো এখন। ঠিক আছে, এটাকে একটা রেশিও বলা হয়। ঠিক আছে, ওটা ডিসকাস করতে অনেক সময় লাগবে, আজকে ওটা যাচ্ছি না।
ওকে স্যার।
এখানে মানে হচ্ছে তুমি যখন ফিচার করতে যাও, ওখানে একটা পিআই বলে, হচ্ছে পার্সেন্টেজ অফ ইনফরমেশন রেঞ্জ, হাউ মাচ within this range I am sure that this should fall within this range. So when you create machine learning model, you cannot be 100% sure. So you say I am saying that 79% something, but within the range 75% to 84% is our range of values. It should be within this percent, I'm sure. I'm saying 75%, but my assumption is it should be within this range. So it is this kind of information. আচ্ছা, এটা আপাতত লাগবে না তোমাদের। গেল। আচ্ছা, এখন আসি আমাদের df.drop. So in the df.drop, you just want to add the features that you want to drop. And there, if you want to have multiple features, you just have to add a uh, bracket here, passenger ID, name, dot, 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 whatever you want. And when you drop these things, you see in when you're using list, when you call a method, like for instance, I have a list, for instance, a.append, and if I just put a name here, H, so it is going to automatically modify your original list A. Okay. So this is, but that does not happen by default in the pandas data frame or numpy add. So you have to add additional parameter that is called, in the additional parameter, you have to say, do I want to do it in that data frame? Like we want to modify the data frame or not? Acha. So df.drop, there is an additional feature that নামটা কি ছিল? Replace তো কি জানি? ভুলে গেলাম।
In place.
In place, in place. Acha. So there is a feature called in place. If you write true, that means it is going to mutate your original data frame. Okay, if you don't do it, it is going to return you the data frame, but it is not going to drop the features in your original variable where you have defined the data frame. That is not going to change. So you have to make sure that in place equals to true. Or if you want to create a new data frame, just write a df2. Okay. So when you are at the beginning, when you are working with different scenarios, it is better you actually create multiple copies of the data frame so that you can actually track, okay, this was up to this portion, I have data frame 1. From here, I have data frame 2, then I have data frame 3, that you can actually go back anytime you want. Okay, so you can also do it. In that case, don't use in place. If not, when you are actually like professional, you can use this in place, you can modify, change your data frame. Achha. So this way, you can drop some of the features that you have. Sure. So you see, we have this passenger ID, name, ticket. So these two features we know how to, we know we want to actually remove. We also remove cabin feature here. So we are going to discuss it a little bit later, why cabin was dropped. And you drop it not just from the training set, you also drop it from the test set. আচ্ছা, আরেকটা জিনিস আছে, axis equals to 1. This is important, very important. Axis means it is the, to say that it is a column that you want to drop. Okay, so you have to mention it. Axis is equals to 1. Okay. So, acha, etu gelo. Any question up to now? Any question? Acha. So we have seen when you have some irrelevant features, let's say irrelevant or redundant feature, যেগুলো আমাদের ছিল, we have dropped that features. Okay. So we have seen 3 irrelevant features, we have dropped it. Next thing, acha, we had some missing values. মনে আছে কতগুলো মিসিং ভ্যালু ছিল? ওকে, আচ্ছা, what are the missing values? মনে আছে? We had missing values in the age column, right? We had missing values in the invert column. We had missing values in the cabin column. আরেকটা কি মিসিং ভ্যালু ছিল বলো?
স্যার এই তিনটাই ছিল।
টেস্টের ক্ষেত্রে মনে হয় আরেকটা ছিল, ফেয়ারে আরেকটা মিসিং ছিল না টেস্টে?
না স্যার, টেস্টের
জি স্যার।
ক্ষেত্রেও আচ্ছা ফেয়ারে একটা মিসিং ভ্যালু ছিল।
হ্যাঁ,
হ্যাঁ,
টেস্টে একটা মিসিং ছিল। আচ্ছা, we had total 4 missing entries. আচ্ছা, 4 features. Now you see there is a condition when you have missing values. The condition is like this: if there is more than 50% feature values are missing, that means you don't have this information. It is better to remove that feature. Like you don't know the information of more than 50% information is missing. Okay. So unless it is very important, you should remove that feature. Is it okay? Achha. So if you look at here, for age, there was almost 177. It is less than 50%, right? For invert, there is only 2 feature missing. For the cabin, there is almost 600 plus feature values missing. ঠিক আছে না? আমি কি ঠিক বলতেছি?
জি স্যার।
Acha. So this is more than 50%, right? The 50% of the data set. So when you have something like this, a particular feature, let's say cabin, you don't know in which cabin the passengers were. So this is a information that you don't know most of the cases. So when you have something like this, it is better to drop that feature as well. That's why in the notebook you saw we remove the cabin feature. Is it okay?
Yes, sir.
Acha. This is one thing. So you can ask the question, what if it is less than 50%? How do you do that? So if it is less than 50%, we do something, we replace the value with something. Okay. So this is entirely this thing's called missing value handling. It is like entire topic, even a research topic, how to handle missing values. So there is a process. The process is called imputation. Okay, missing value handling. This process is called imputation. Okay, in the next stage, we'll see we'll talk more about imputation before we go there. Is it okay? If you have more than 50%, remove that missing values. And if you have something less than that, you impute your values. Achha. What is imputation? We are going to talk a little bit later. Achha. Number three. Mapping. So previously you saw some of the variables like string but categorical. Okay. So male and female. For instance, it was written as male and female. We want to convert them into numeric values. Okay. We want to, let's say, make the male as 0, make the female as 1. Okay, something like this. So that we can actually now perform any numerical computation. Okay. So that is something we have to do. So we can do it very easily. There are several ways. When you have something simple, there is a function. Let's say I have the data frame. I want to call this variable. Okay. Then have this function map. Okay. I want to map. I think I already showed you in the second lab here. In the map, you insert a dictionary there. And in the dictionary, you say, what do you want to replace it? I want to replace male as 0. I want to replace female as 1. Your dictionary close. So when you call this function, it is going to replace all the male and feature values with 0 and 1. Is it okay? Is it okay?
Yes, sir.
Okay. So if you come here, you can see also you have to define it in the new variable. So I am changing this variable and mapping it 0 and 1, female and male, and replacing it into this value. So you can see now this value is now changed. It has now become 0 and 1. Previously it was male and female. Now it is 0 and 1. Achha. And S type is given as integer. That means I want integer. By default, it is floating. So if you don't use S type, it is going to output is going to be 0 dot something. But I don't want that. I don't floating point. So I can actually mention the exact data type I want, integer. Okay. And you do it for train and test both. You can do it for train and test both. Also, we had another feature invert. So we had 3, S, C, and Q. So I can replace it as 0 and 1 and 2. And now you can see, I did not use the S type equals to integer. Now you have 1.0, 0.0 like this way. Okay. So it is better if you have integer value. So just use S type equals to integer. It is going to give everything in the integer value. Is it okay? Any question? Any question? Achha. So right now, as you can see, this is our data frame. There is no other string value. Achha ki kono string value? Nine. So all the string values has now converted, either deleted or the categorical string value we have converted into 0 and 1. Achha. And there are some missing values that we are going to deal with it now. So missing data handling. So we are going to deal with it. Achha. How to deal with it? Let's see. So there are different ways to address the missing value. So map is one approach. You will see some other ways to do it in the next notebook that you see.
স্যার ম্যাপ দিয়ে কি আমরা মিসিং ডাটা হ্যান্ডেল করতেছি? আমরা ম্যাপ
না।
দিয়ে নিউমেরিক্যালি কনভার্ট করতেছি না ক্যাটেগরিক্যাল ডেটাকে?
হ্যাঁ, ম্যাপ দিয়ে আমরা নিউমেরিক্যাল ক্যাটেগরিক্যালকে নিউমেরিক্যাল বানাচ্ছি। মিসিং ডাটা
আচ্ছা
হ্যান্ডলিং
আচ্ছা
ডিফারেন্ট, কমপ্লিটলি ডিফারেন্ট। ইট ইজ নিউ টপিক। ঠিক আছে। আচ্ছা, সো মিসিং ডাটা হ্যান্ডলিং when you have less than 50%, 50 feature value, something that we want to use that is called imputation. আচ্ছা, এখানে অবশ্য আরেকটা জিনিস আছে যেটা মেনশন করতে ভুলে গেলাম। So this is for column, right? This is for column. Sometimes it happens that for sample, for a particular sample, lots of columns have missing values for a particular sample. আরে এগুলা শেষ হয় না মিটিং। আচ্ছা, for a particular sample, so similar, let's say for a particular sample you have, let's say ID 800. For that one, out of 12 features, 8 features are missing. 8 features missing. So in those cases, it actually sometimes happens that for one particular record, you do not actually get most of the data. So you should also check the row as well. So previously you check the column wise, you should also check the row wise, that if there are any rows for particular rows, you had that much actually information missing. And same thing, if there is more than 50% information missing for a particular sample, you should remove that sample. Is it okay? বুঝে গেছে আমার কথা?
Yes, sir.
But here is a catch. The thing is, you should go, whatever I'm showing you, you should go stepwise. You should not go to sample first, you should go to column first. Acha. Because you see, if you remove a column, you remove some information, but when you remove a sample, it can be issue because you see number of samples are limited. And in machine learning model, you need more samples as much as you can. So we don't want to remove any sample from the data, actually. So if it happens, let's say, for one sample, you have most of the information missing, but it can happen that for one value, let's say age, out of the 890, for not age, আরেকটা গেছে, কি জানি দাঁড়াও, fair একটা ছিল, fair information was missing, but we know the fair information of 890 passengers. From this one, we can get some idea what should be the fare of the other passengers. We can get some idea. There are ways to make sure we can actually get it. So you should be cautious when you try to remove any sample. This is not something you should do. You should do up to this now for now. Okay, but this is something we can do later. We'll see. For now, you don't have to worry about it. When you get much more familiar with this machine learning, then we'll see. We can also sometimes may actually want to remove some samples as well. But for your case now, in the introductory level, you don't have to worry about this one. You worry about the column now for now. Acha. So when you have the column, we perform an operation that's called imputation. Acha. Imputation means replace the missing values. Replace missing values. Okay. So whatever the non-values that we have, missing values, that means wherever you have the non-values, we want to replace it. So you can ask this question: what do you want to replace it with? কি দিয়ে replace করব? আচ্ছা. So that's where the imputation term comes from. So this process can be divided into two types. One is univariate imputation, univariate, and number two is multivariate imputation. Univariate is taking one column at a time. Multivariate is taking multiple columns at a time. Achha. It means, for instance, let's say univariate. I have the H column that has many missing entries. So there are like how many ছিল? কতটা জানি ছিল? 100টার প্লাস, 150টার মতো. So out of 150 plus, out of 891 samples, I have 150 plus missing values. So what we can do actually is that of the remaining samples that we have, 891, we can take the mean as mean of that column. Now, যাবে না? Or we had this embarked feature. So there are like embarked এর জন্য দুইটা ছিল, 2 out of 891 missing. So, but it is a categorical value, so it is like frequency. So you can take the mode, that means what is the most frequent? Is it 1 or 2 or 3 most frequent? So what you do, the missing values that you have, you replace the missing values with the mean of that original mean of the data set information. Okay, so you take the mean of the H column and replace those values with that value. For categorical features, you take the mode, for instance. Mode value, so if 3 is the most frequent, let's just replace it with the most frequent one, because that is the best chance that you can actually get that missing value should be the highest, most frequent. Is it okay? বোঝা যাচ্ছে কি আমার কথা?
Yes, sir.
But does it give you the accurate information? It does not give you the accurate information because you are saying that like there is 60% chance, let's say, the passenger is from third class. But it can happen the missing values is from first class passenger. It can happen. We don't know. So when you are using this univariate, you don't use the information that is the other feature information. You just rely on a particular information. So this is more simpler way of imputing a feature value. আমার কথা বোঝা যাচ্ছে? So this is simple. So when you do it, you do this univariate one when you have a small number of missing entry. So if you have a small number of missing entry, like 2 or 3, and if the column is not that much important, then you can just simply use univariate. Just, okay, H column, okay, does not mean anything, doesn't match much. So say, let's say if you take the mean, it should be like around 30. Okay, fine. So when you have very small number of missing entries, you can actually go for univariate. And this is very simple to apply. But when you are much more critical later, when you start actually doing machine learning model, it is more critical. You should rely on multivariate. So what is multivariate? In multivariate, you take the information of surrounding columns. So let's say you have the age missing. You take the information like what is the sex of that, if it's a male or it is a female. So then what is the imbirth? What is the child? Where did he imbirth? Then sub-SP, okay, siblings and spouse, then parents and children. You take the information of all the other columns, okay, then try to predict based on this column. Predict if if the person is from sex, like think of it like a conditional statement. If the person is male, if the impact is this, what is the chance that this person is going to be? Just like your linear regression, you have studied linear regression, right? Regression person.
Yes, sir.
So it is actually trying to do the same thing. It is going to perform a linear regression model and try to predict that particular feature variable based on the other feature information. বোঝা যাচ্ছে আমার কথা? বুঝতে পারছো না আবার বলবো?
বুঝতে পারছি।
Yes, sir. বুঝছি।
আচ্ছা, so this is what replacing imputation means, okay, missing data handling. So univariate imputation, multivariate. So in univariate, you try to replace the values with something simple like statistical information, mean value, frequent value. If you have like a continuous data, you take the previous value, things like this. In multivariate, there are some algorithms. One of the most popular algorithm is called MICE. Multivariate imputation by chained equation. মনে থাকবে? আচ্ছা দেখিও তুমি, ওখানে আমার লিঙ্ক দেওয়া আছে, তুমি ইয়াতে নোটবুকে লিঙ্কটা দেওয়া আছে, তোমরা ওখানে দিয়ে দেখতে পারবা সাইকিট-লার্ন লাইব্রেরিতে। সো মাইস ইজ ওয়ান অ্যালগোরিদম দ্যাট ইজ দ্য মোস্ট পপুলার, and this is something we apply when you want to impute the values. You don't have to worry about those things because most of the things will be like all of the things will be done within this algorithm. You just have to call the function, nothing else. You don't have to worry about anything else. Acha. So if you look into the notebook now, so this is the missing value imputation, and this is the scikit-learn library. Okay, if you go there and you can actually see, you will find everything, every information, all the imputer that is available, you can find it there. So I hope you have the idea is clear. Now you can ask this, how to actually apply it. Okay, now this is a question, how to apply it. To apply it, first you see, I call this function and we are calling it from scikit-learn.impute. So scikit-learn library, inside the library there is a class that is impute class, and here I am using simple imputer. Simple imputer is for univariate imputation. Okay, for multivariate there is another function. So how to do this? Let's see. I have this simple imputer method. So what you do here when you try to do it, you create an object, simple imputer object. Okay, you create an instance of the object. I believe you already understand these things. So what you do when you try to impute it, you create a object, let's say called simple imputer. Okay, and inside, if you look at here, let me go here. একটু দেখাই তাহলে তোমার বুঝতে ভালো হবে। ওকে, আচ্ছা, so you can see this is imputation of missing values, univariate, multivariate. Okay, and you can see this is the simple imputer. Yeah, is the given here multivariate. Okay, and you can see here scikit-learn dot experimental enable iterative imputer. So iterative because you are using multiple iteration. So that's where the mice algorithm actually comes. So you have to use this one when you are try to go much more better imputation. So acha, so using this one for multiple, there is nearest neighbor imputation. This is one. Okay, mice এখানে দেখাইনি। আচ্ছা, search for it in the scikit-learn, you will find the mice algorithm as well. I hope. Acha, let's go back. Let's go back and come here. So what you do, you create a simple imputer object. And inside, inside here, inside the bracket, okay, inside the bracket, you mention. Mention means what by which you want to do it. Okay. By default, it is going to take np.none as the missing values. And you have to mention, do you want to use the mean value? Do I want to use the mode value? That is something specifically you have to mention. So I think this is the parameter name called strategy. And let's say I call it mean. Okay. So oh, no. আচ্ছা, আসছে। গেছিলাম মিসিং ভ্যালু আচ্ছা, হ্যাঁ, মিসিং ভ্যালু। আচ্ছা, সি স্ট্র্যাটেজি that is actually mean, and by default the missing values are np.none. আচ্ছা, so we don't want to worry about np.none here. So this is the strategy, so you can check and make it something else for your other thing. You can use mode for different columns, you can use different one, whatever you like. For this one I have just used common for all the data set, make it simple. Acha, now, so this is your object, and so this is your object simple imputer that is going to perform imputation based on the mean value. Acha. Now you want to apply this object on the data set that you have. Acha. So when you try to apply it, there is three things actually, three function. One is fit transform, and another one is transform. Acha. So there is one issue that is called একটা করে আগাই। Fit means if I call this simple imputer, let's say, acha, so if I write it like this way, so this is by imputer object. Okay, so I am calling the method fit on the train df. Are you following?
Yes, sir.
Yes.
Okay, so when you call this fit method, what this one is going to perform, this is going to calculate the mean of the each column. When you call fit, it is going to fit on the data. That means on the trained data set, it is going to calculate the mean of each of the column. It is not going to do anything else. It is just going to calculate the mean value. That's what the strategy that you have defined. And it is going to calculate the mean values of each of the column. Is it clear?
Yes,
So
sir.
can you repeat
Yes,
it
sir.
again?
So, acha. So this is what we are doing. First, we are creating an imputer object. It can be iterative imputer or simple imputer, and you are mentioning what you want to do. I am creating a simple imputer object with the strategy mean. So what this one is going to do, it is going to perform simple imputer with mean values. আচ্ছা, so it is like, for instance, knife. Previously I gave you an example. Knife is an object, so this is like an object. What you can do, you want to cut something with it, you can actually stab someone with it. What you want to do, that's up to you. So this is the method. So if you want to do it, so you have to call it like this way: knife, that's the object, dot cut, and cut hot. বোঝা যাচ্ছে? আচ্ছা,
Yes, sir.
so knife is the object and you want to stab. Who want to stab? কাকে stab করবা? নাম না বলি থাক। আচ্ছা, so you want to stab someone,
Sir,
that's the
this,
name. হ্যাঁ?
sir, this space that empty, that's going to be the object that you want to cut.
Yeah, which one, the person, the object that you want to do. That's where you want to apply this object.
Yes,
Similar,
the one that is having um the
the data.
space, this yes,
Yeah,
that's the object that you want to cut.
yeah. So if I have the imputer object and I want to use the function method fit. So I want to fit means fit on the data. What is the data? Let's say the train data set. So what this one is going to do, it is going to calculate the mean values that is we have defined of that data set that you have. So it is going to calculate the mean values of all the columns of the training data set. Is it okay? ঠিক আছে?
Yeah.
আচ্ছা, so that means it is just going to calculate the mean value. It is not going to do anything else. But what you want to do, I want to impute. So I want to replace the missing values with the average value. So then you have this function imputer imp dot fit transform. If you use this function on the train df, so again, this is going to first fit it, then transform it. Transform means it is going to replace all the missing values with the, this is going to replace all the missing values, that's the non values, with the average of that column. বোঝা যাচ্ছে আমার কথা? Is it clear?
Yes, sir.
So this is the thing. If you want to fit it, just fit on a train data set. If you want to transform that, you just use fit transform. So then all the training values that you have, all the non-values, it will be replaced with the average value of the data set. Okay. So if you now try to do it in your notebook, let's see. So let's say here, I try to call this one. আচ্ছা, output will be numpy, that's an issue. আচ্ছা, ওটা পরে আসতেছি. So if you check this, আচ্ছা এখানে পরে আসি. If you check it, after you perform this fit transform, you see there is no more null values are there. All the null values are being replaced with the average value. Okay, আচ্ছা ওখানে একটু পরে আসতেছি, 10টা বাজে গেছে যেহেতু। আচ্ছা, so this is your fit transform, it is going to replace it. But here is a catch. When you try to transform it, you do it for the training data set, fit transform, but never fit on test data. Very important. Very important. Never fit on test data. Why? There is an issue that is called, this is an issue. This is called data leakage. Data leakage. This is a very critical issue of machine learning. Achha. So the idea about test data is you have some unseen data that you don't know any information. Okay. And the test data is individual. So you have one test sample at a time. So if you have one test sample at a time, how do you can calculate the mean value? বোঝা যাচ্ছে আমার কথা? So do you understand? When the test data means you have individual sample coming to you one at a time to test the values. That's your testing. You don't know any other information of the test data set. Okay. So if you don't know any other information, how can you get the average value of the entire data set? Although I am providing you all the 100 sample at the same time, but you don't actually have it. Okay. That's just provided. You are supposed to do it one by one. So that's why we never fit on the data, test data. So then what do you do? What we do, we use the fitted model, fit on train data. Then using this fit model, you transform your test data. You're going to find it multiple times. So this is the approach. So you fit on your train data, but you use this one, fit and fit transform for your training, but use transform only for use transform for your testing. you only transform your test data. You don't actually, so all the missing values will be transformed, but you don't fit on the data. Is it okay? বুঝে গেছে আমার কথা
স্যার
নাকি কমপ্লিকেটেড? সো
স্যার ট্রান্সফর্ম করব কি দিয়ে? আমার তো মিন নাই।
টেস্ট মিন আছে, আমরা তো ফিট করছি ট্রেনিং ডাটায়। So when we feed the object in the training data, it is holding that values, right? The
Holding the mean
average,
values from the training data,
yes,
right?
mean values of the age training data. And we are going to replace all the values in the missing values using the mean values of the training data. Because training data
আচ্ছা
is what we have available. We don't know anything about the test data. So for sake of our model to work, we just have to replace with it someone. So the best assumption that we can get is replace it with the mean values that we have, information that we have from the training data set. That's it.
বাট স্যার ট্রেনিং ডেটার সব মিন ভ্যালু তো মানে আমার টেস্ট ডেটার জন্য,
Valid
বাট
হবে
এটা
না।
বেস্ট, হ্যাঁ এটা বেস্ট আর কি, দ্যাটস দ্য বেস্ট
এটা
উই ক্যান
বেস্ট,
ডু।
it is the best assumption that you can actually get. It is not perfect, but that's the best that we can do. Otherwise আমাদেরকে রিপ্লেস করে আমাদেরকে রিমুভ করতে হবে, but we don't want to remove any sample. That's why this is the best option that is available to us. Is it okay?
ইয়েস স্যার।
আচ্ছা, so imputation আসলো training and testing. So when you have training, you fit on the training data set, you transform the test training data set. Okay, fit on it, transform. But after you fit it on the training data set, then you only transform it, but never fit it. আচ্ছা, so this is what you have to do. And if you have look at the notebook, you will find it there. One problem with this application is that the output will be a numpy array. Okay, so you have to convert it back. So you just have to convert it back. Pandas dot data frame of this array, it is going to convert it back into a data frame again if you want to do it. Acha, any questions up to now? Okay, so let's move on. So this is one of the issue that we have, missing data handling, and we have seen we have done it. So there is no more missing values there. Okay, acha. Now, so that are the most of the issues that we find. We had some of the issues like some of the columns are redundant. We remove that columns. Some of the columns had too many missing values. We remove that column. Some of the missing values, a small number of missing values, we perform imputation. I have shown you a simple imputer. You can also test with multiple imputers. Same way, you create a imputer object, then perform fit and transform. That's it. Acha. Now then, the correlation analysis. Correlation means this is the Pearson correlation actually. There is a function called CORR, correlation, COR. It is going to give you the correlation among the variables. And if you put a heat
স্যার,
map,
একটা কোশ্চেন ছিল।
বলো,
স্যার, what if we use drop না function to just drop the non values? তাহলে কি হইতো? মানে এত ঝামেলায় নাকি?
drop the non-values,
হ্যাঁ,
তাহলে আমার ডাটা সেটটা অনেক কমে যেত না?
আচ্ছা আচ্ছা।
So if you, let's say for instance 891, you have 200 passengers, you don't know the information of age. If you remove 200 passengers, that means your data set is now 691. এটা কি ঠিক হলো? তোমার ডাটা সেট বেশিরভাগ ইনফরমেশন তুমি রিমুভ করে দিলাম, ঠিক হলো না, তাই না?
Yes, sir.
Okay, so that's why we want to replace it with something, because this is just one information, but we have the other feature value information there. So best way is to use multiple. Mice is the best algorithm that you have. So most of the time you can use mice. Okay, so work with the information that you can have. Okay, acha. Now correlation analysis. So this is called a heat map. You have the heat map function in the Seaborn. So you can see I am calling it from sns.seaborn. You already know how it is the figure size, how to control the figure size. Acha. So here you can see on the x-axis you have the features. In the u-axis also have the features. Again, you have to maintain the serial that I'm providing. Okay, this is important. This is called the pipeline. Okay, so this is the data analysis pipeline. If you try to do it before mapping or missing data handling, things like that, this is going to give you error information, erroneous information, especially for string values. You will not get anything. Okay, so you have to make sure you are following the pipeline that I'm showing you, one step after another, and then you will get everything clearly. Acha, now, so if you look at this correlation heat map, so on the x-axis, y-axis, you have the same feature, and the middle row, that is the diagonal row, everything is one, because this is the correlation with the same value. So this is one. As for the other one, you can see the correlation values. Correlation. So in the correlation, Pearson correlation, you have -1 to 1. Now, there are some issues. If you actually know more about correlation, there are something for numerical values, something for categorical values. There are other correlation other than Pearson correlation. So for now, for simplicity, I'm just looking into Pearson correlation. You can look into more detail if you're interested. There are other correlations are also there. So the correlation value starts from -1 to +1. -1 means completely opposite. 1 means completely positive. Acha. 0 means no correlation. Acha. So that's why our scenario. If it is -1, that's fine for us because that means there is a relation with the target variable. 1 means that's fine, but 0 means no correlation. Then when it becomes actually much more critical for us because that does not add any information. So if you look at some of the thing, for instance, this is our target column, survive. With the target column, if we see with the fear and the survive column, what is the correlation value? Fear and the survive column কত ভ্যালু দেখা যাচ্ছে 0.26, right? So that is the
Yes,
value
sir.
that we have. So that means with fear there is some good information is there, relation is there with our survival. Okay, so because you can understand passenger class 1, first class passengers had a higher rate of survival. We have seen it in the visualization. So obviously first class passengers had higher fear, so that's why you can get some information there. But that's it. And also passenger class, if you look at the survival with the passenger class, you have -0.34. Passenger class with survival, you have -0.34. So that is negative correlation. Fine. And if you look at fare and passenger class, you can see there is very high relation, -0.55. So because fare and passenger class is very related, that's why you have higher correlation value. So this way you can actually check which are more highly correlated, which are very less correlated. So for instance, if you look at here, the top row, you can see 0.035, very small, very close to 0. So it is not finding sibling spouse. It is not finding any information here. So sibling spouse, number of sibling and spouse. With this one, it is not finding any information with the survival rate. বোঝা যাচ্ছে আমার কথা?
Yes, sir.
So again, PRCH, that is parents and children also, it is almost close to 0. 0.0, that means 0.1 এর কাছাকাছি. So this is very small. So it is not finding much relation with that variable. So in a small data set, we don't worry about these things. But in large data set, when you have many features, if you have too many features, okay. Acha. There is a term that is called curse of dimensionality. Curse of dimensionality. So the thing is, if you have too many features, like 100 plus, then your machine learning model has some problem identifying proper reasons. Problem means it actually gets bias. Okay. Some of the features, too many features, if there is too many features, it is difficult to have a very accurate machine learning model because there are so many information, it gets overwhelmed. Okay. So it is better to keep the features, keep the most relevant features in your predictive model. Later you will see feature selection, other things. But for now, so when you have very small number of features, we don't worry about it. But when you have very higher number of features, you may remove. There is another condition for removal. Remove less related features. So the features that is very close to 0, less correlated correlation. The correlation is almost close to 0. That means it does not have any correlation with my survival variable. In that case, we can actually remove those features. That will reduce the feature size. But if you have like 10 or 15, you don't have to worry about it for now. Acha. Is it clear? আমার কথা কি বোঝা যাচ্ছে?
Sir, negative correlation হলে তো ওটা important, right?
হ্যাঁ, negative or important. Close to 0. So what do you do actually? We take the absolute value. After this one, we perform the absolute value. It is give you the positive value. Then you check anything less than 0.05, you remove that. we can give a condition there. Any feature that has correlation less than 0.05, remove it. Is it clear?
Sir, fare and passenger class, they have a negative correlation of minus 0.55. It means it's important, but why it's negative?
It is important. Relation is important. Negative means it is just changing in the opposite direction. So
Okay.
like if that means it is affecting in the, instead of the survival, it is affecting the non-survival. So it works like this way. So that doesn't matter to us. What matters to us is the information statistically important to us or not. Okay. ঠিক আছে?
Yes, sir.
আচ্ছা. So this is one condition of, another condition of removing. Like I said, when you work with many data set, 5 or 6 or 10, then you actually start to notice all these things one by one. For now, keep these things noted in your notebook. Acha. So we have seen, we have visualized these things. Acha, and this is your annotation. You see, this is annotation equals to true. This is the right side column. You can see this is the annotation. You can put a color part there. Acha, থাকলো. So last thing about feature engineering, one thing. So sometimes you may want to create new features. New features means, for instance, we previously seen that CVSP, Parch, these are not actually adding any information to you. Adding information does not have much relation with your survival column. So what you can do, for instance, see, create new features. Acha. So you have this sibling and spouse, number of sibling, number of spouse. Then you have parents and children, number of parents and number of children. Acha. So all these things, they actually more or less represent the same thing, right? And if you remember the data type, that was the first thing, the analysis, you will see there were 7 or 8 categories there. মনে আছে? ছিল না 7-8টা? কারো ছিল 0, কারো 1, 2, 3, 4, and we have seen the variable, we have seen that the chances of survival was different for different scenario. But you see, when you have this kind of variation, it doesn't actually make sense. What is the difference if a person has 2 siblings or a person has 3 siblings? What can be the difference of survival? It doesn't actually add those information. So when you're using this data analysis, you have to use a lot of intuition. Okay. Intuition about the concept. You have to have the domain knowledge. All these things actually come into play. So use a simple intuition, like there is not much variation. 3 and 4, there should not be much difference. So that information is redundant. Okay. So the variation into 3 and 4, 5 or 6, this information is redundant. Achha. So what you can do, we can create a new feature like, for instance, family size. So I'm a new feature called family size that adds these two, CVSP and Parch, the summation of these two. Okay. So how do you do it? You just create a new feature, let's say family size. You know how to do it. Then take, it is like NumPy array. You can just do it, CVSP plus definition of eto, Parch. Okay. You can directly add those things. It is element wise. Okay. So this is create a new feature called family size, where you have the summation of these two. So now it becomes like 0, 1, 2, 3 up to 15 হয়ে গেল। তাহলে কি ভালো হলো না খারাপ হলো? ক্যাটাগরি তো আরো বেড়ে গেল। ভালো হচ্ছে না খারাপ হচ্ছে? ভালো হচ্ছে না খারাপ হচ্ছে?
স্যার এটা সার্ভাইভ কলামের সাথে ম্যাচ করে মানে কোরিলেশন বের করে দেখতে হবে যে ভালো হচ্ছে না খারাপ হচ্ছে।
আচ্ছা, হ্যাঁ ঠিক আছে, but you can just get some intuition, like when you have like 15 different categories, obviously the relation is not going to be very accurate, right? What is the difference between 3 and 4? বোঝাচ্ছে আমার কথাটা?
ইয়েস স্যার।
So আচ্ছা, যেটা আসলে বলতে চাচ্ছি আমি আসলে, we want something much more statistical information, like category 0, 1, 2, 0, 1. These are much more like gives you much better information. So if you have something binary or 1, 2, 3, 4, 5, 6, like a small number of category, like male and female, this gives you more information about the percentage of survival or not. When you have like 15 different categories inside one feature, that makes it much more complicated. So we can create a new feature from this family size that is alone. That is whether the person was alone or not. if you remember from previous statistics that you have, 0% was around 30% passengers who survived, who did not survive was 0. মনে আছে? এরকম একটা দেখছিলাম না? এই যে এখানেই সব অ্যানালাইসিস গুলো আস্তে 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 আসে। প্যাসেঞ্জার ক্লাস কোথায় দেখছিলাম একটু আগে, দেখি এখানে দেখছিলাম, হ্যাঁ দেখতে পাচ্ছ? So you can see here 0, that means a person did not have any sibling or a spouse. He has like 34% chance of survival. Okay, so what you can do, we want to categorize into two different category, 0 and 1. The person had any or was alone or not. Okay, so same thing here, part 0% is 34. So this is how we actually define a new variable, is alone. Then you give a condition. Condition is if the data frame of family size is equals to is equals to 0 or 1, whatever that is. If you do it like this way, then you can say your variable will now become binary, 0 and 1. The person was alone or not. Then you can actually relate whether what is the chance a person was alone and he actually survived, and what is the chance the person was not alone and actually survived. Does it not make more sense to you? Instead of having 3 or 5 or 5 or 6 or 7 sibling and spouse, it makes more sense, like much more clear relation. If the person was alone, what is the chance of his survival? বোঝা যাচ্ছে আমার কথাটা আমি কি বলতে চাচ্ছি?
Yes, sir.
Sir.
So this is this is kind of intuition that you actually use to create a new feature variable. That is something you can do. Okay, and so you have the code to do it here. So from is alone, now you have the code here, you can see. So we have now created a new feature called is alone. Okay, so once you do it, is alone, you can actually remove this sibling, spouse, parch, family size, all those 3 features remove, right? You can drop it. So I am not done it. It is up to you. You will do it. So remove that feature and keep this is alone feature. Then perform your correlation analysis again. বোঝা যাচ্ছে আমার কথা?
Yes, sir.
So when you perform this correlation analysis, then you see what kind of heat map that you get. Now do you find much more better relation with the survival column or not? আমার কথা বোঝা গেছে? বোঝা যাচ্ছে?
Yes, sir.
Yes,
Okay,
sir.
so this is your task. This is your class task. You have to do it a little bit later. Is it clear what you're trying to do? কার কোনো কোশ্চেন আছে?
তো লাস্টে কি করতে হবে? আমরা ইথালন দিয়ে করে পুরো হিট ম্যাপ বানাবো।
হ্যাঁ, এবং এই যে ইউ সি লেট আস ড্র পার্ট সিবিএসপি এন্ড ফ্যামিলি সাইজ, এই 3টা ফিচার রিমুভ করে দিবা। রিমুভ দিস 3 features and make the correlation heat map again and see now what is the relation. Previously you saw that parts and CBSP the correlation was 0 point something. Now you can you get actually better correlation from is alone there. If you can get better correlation, that means the feature that you created is much more effective, will be much more effective in predictive modeling. ঠিক আছে? Okay, আচ্ছা, any question from anyone? Any question?
স্যার
হ্যাঁ বলো।
স্যার ফ্যামিলি সাইজে +1 কেন করা হয়েছে?
এটা জাস্ট দিয়ে দিছিলাম হচ্ছে লাইক 0 রাখার চাইতে 1 রাখার জন্য। ওকে, এটা এমনি এমনি করছিলাম, ওই সময় যখন লিখছিলাম তখন করছিলাম, না করলেও কোনো সমস্যা নেই। ফ্যামিলি সাইজ 1 মানে হচ্ছে, তুমি যদি চিন্তা করে দেখো একটা পার্সন যে 1 আছে, যে একা, তার তো ফ্যামিলি সাইজ মানে 1, তাই না? সে একা হলেও সে তো একজন, 0 বলতে পারি না ফ্যামিলি সাইজ। তো দ্যাটস ওয়াই ওটা আমি ওই সময় করার সময় 1 অ্যাড করে দিছিলাম। ইট ডাজন্ট ম্যাটার, সেম থিং, সেম কনসেপ্ট, জাস্ট তোমার ইয়াটা একটু চেঞ্জ হবে, কন্ডিশন উইল বি এ লিটল বিট ডিফারেন্ট, দ্যাটস অল। Any other question? Acha, so this is your entire pipeline we have seen so far today. So this is the pipeline of EDA pipeline that we have seen today. Okay, exploratory data analysis pipeline, and the goal was to prepare your data. So from the beginning, if we just try to combine everything into one thing, so first you start with the data, import the data, import the libraries. Okay, then you try to see the variables you have, what are the columns that you have, what those columns represent. Try to understand the data set. This is more important. Okay, then try to find some issues. Okay, issues means what are the features that are relevant to you directly from intuition, what are the features are not. how many missing values are there. So is there any like string value, is there any issues there? Okay, anything that you need to handle. So try to find some issues, then try to ask some questions or make some queries. Okay, try to understand what is the relation with the survival, what is the relation with the output variable. Okay, try to understand with each feature variable, what is the relation with the output variable. Try to understand those things. This is the query to understand. So, and in your assignment for this week, this is what your task is. I have not given you any specific queries. I have given it up to you. You try to imagine your queries, that how do you want to find from this data, and you write that question and write that answer and try to show it in the notebook. I will see. Okay. Then after this one, when you try to go for this query, then you want to go for some handling. You want to remove some of the features you might want to remove. For missing values, you want to perform some imputation is there. Okay, these things you want to do. Okay, then you some cases you have to some of the feature information some you have to map it. If you have some string value, you have to map it to numerical value. So map for numerical, this is important. If you have a string value, it will not work. You have to map it into a numerical value. It is there. Then sometimes you have to have some like string value there can require some processing, definitely. String value, date time value. For instance, this kind of processing, let's say your data is like given here 2010 1997, but you are more interested in the year, you are not interested in the date and month. So you can actually have to extract the year from it. Okay, you can extract the year using some function there. You can extract the year, so that can be your new feature. So that kind of processing might require from this kind of string value or date time value, things like that. So then you actually try to perform the correlation analysis to understand the correlation between different features. Okay, so sometimes from this correlation, you might want to remove some features as well. Okay, or you can actually, after that, you can actually create some new features that can also be one issue. Yeah. Gotcha. So this is like the entire data analysis platform pipeline, EDA. You try to do those things whenever you start working with a data set, you try to do it and keep a separate notebook for just for EDA. Try to understand. And once you are ready your data, you keep your data like 2 CSV. Okay. Using your data frame, whatever you have 2 CSV, save it so that you don't have to repeat it. So you have your original data, raw data at the beginning. After all these things are done, all the processing, save it. Now, based on this data set, like after you're done with the tightening data set, based on what you get, on that one, we are going to perform predictive modeling in the lab 4. Is it okay? Any question? Got a question? Okay, so let me show you very fast another example. So this is one example, and I actually provided another example so that you can actually get some better idea in this one. Okay, so this is your KDT cup dataset. KDT cup is another very popular dataset, and the data is actually, the original data is very large, around 4 million samples are there. Now, training your model of 4 million samples can be a bit tricky. So what, for common purposes, you use 10% of the data set. That's like 400,000 samples. So if you go to the data repository, you also find the 10% data set that is also there. So in the KDT cup data set, this is for network intrusion detection. Okay, so the data set, KDT cup, KDT is knowledge discovery from data, the short form of knowledge discovery from data, KDT. This is a competition. There are many machine learning competitions are there. So in the KDT, it is for network intrusion, cyber attack. This is basically, it is for cyber attack. Okay. So in this kind of cyber attack, so let's go. So I'm going to go it. I'm just going to show you most likely. So let's start from here. You can see, you already know the pipeline. Let's see. This is the data, and what is the file format of the data set? Format means হচ্ছে ফাইলের ইয়াটা কি, এক্সটেনশনটা কি?
.gz.
.gz, that's another type, but it is like a CSV file. You can use the CSV to do it. Acha. Now you can see I have used header equals to none. Okay, and there is a specific reason I do this. If you don't use header equals to none, because you see in this data set, this is like a text file. and it did not have any column values there. Okay, separately column values are written. So if I don't use header equals to none, the first row, the first sample now will be automatically assigned to the column variables column. If you can test it when you try it, definitely test it. Okay, so that's why I have used the additional function header so that you can get the columns now. And you can see there are 490, almost 500,000 samples and 42 columns. ঠিক আছে? So again, the same pipeline, try to understand the data set. And these are the column values, the column names. Okay, so this is collected from the dataset, original dataset repository. So you can get all this information there. And I replace the like column names with this one. So now we can see what is everything actually means. So you have duration, protocol type, TCP, then other things are there, service type, HTTP flag. Okay, there are different information. I don't even understand all those things. Acha. So you don't have to understand every feature variable. Okay, for a different data set, you may have some features that you don't understand, but you can still perform EDA, you can still perform machine learning from there. Okay, this is specifically for cyber attacks, so that's different. So after I have done it, I have just save it. Okay, and this is the target variable. See the outcome, and there are many target variables, right? How many? Almost 15. Acha. So you see, previously we had survival column, we have 0 and 1. When you have, this is called binary classification. I'm trying to perform some classification like binary classification, 0 and 1. And when you have too many, that is called multi-class classification. Later, we will actually see, we can actually combine it into attack type and combine it into 5 different categories. Okay. Like DOS attack, normal attack, probe attack, R2L and U2R. These are like attack types. So all these 15 categories, we can actually combine it into subcategories, like 5 different. So all these subcategories, we can combine into categories so that it becomes much less class. So the higher number of class, the more complicated the classification tasks become. That's why we want to keep it low. আচ্ছা গেল, ওইটা গেল. See, can you see some error issue with this data, with the values? কোনো issue কি নজর আসতেছে? You see this dot there after this Smurf or Neptune? There is a dot there, right? Ase?
Yes, sir.
This is a problem, right? It should not be a dot. Okay. So that's why you see I have used the rstrip function to remove that dot. Okay, this is an error. It should not be like this. So that's why I first process the data set, convert it into string, then rstrip, strip that dot from that. Then I replaced it with these values, with the attack types. You can see the code. You can definitely find it. That is, it should not be a problem anymore. So now we have this data. Gel. Our outcome time fixed column. So my outcome is fixed now. And now these are the data types. There are too many features for you to analyze, like 42 features. So how we are going to analyze? So we want to keep it simple. And the features are not very specific, just like previously, like age and then gender. These are very specific, but now we have too many features, too many information. Then we want to get the overall idea. Acha, missing value. Is there any missing values? No, done. Missing values 9. Acha. Now, duplicate is another issue. Sometimes there are duplicates in the data, duplicates in the row. Previously, I did not test it. So like I said, in different data set, you will face different issues. But in this one, you can see there are duplicates. So you have to test for all data set. In the previous one, I knew there are no duplicates. So that's why I did not test it. But now you can see there is a duplicated function. And it gives you the duplicate number of rows, not columns. And how many duplicates are there? Follow, কয়টা আছে? কয়টা দেখা যাচ্ছে? দেখতে পাচ্তেছো?
Yes, sir.
Yes, sir.
34436.
দেখা যাচ্ছে না, হারাই গেছো?
দেখা যাচ্ছে।
আচ্ছা, so there is like 350,000, right? Almost. Our original data was 500,000 and almost 350,000 are duplicate rows. তাহলে কি ভালো হবে? আচ্ছা, when you have duplicate rows, actually it does not add any additional information. So there are some duplicates are there because the attack times, sometimes normal things, normal data, the same thing is coming again and again. So in this kind of data set, there can be duplicate. But duplicate rows does not actually add any new information. Rather, it can bias your model. So that's why it is better to remove that. So there are too many duplicate rows, so you can drop duplicates. There is a function. Just like your drop column, there is drop duplicates. And you don't want to drop everything. You just want to keep one, right? You don't want to drop every duplicate. So you have to mention that keep the first one. Okay. Now you have data set is like 145,000. Okay. Now the data set size is much lesser, much less than your original one. Is it clear? বোঝা গেছে আমার কথা?
Yes, sir.
So you learned a new thing. You should also check duplicate rows. This is another issue that can happen. Okay. So the more you find, more you actually exercise in the data set, that's what data science is actually about. The more you practice, the more and issues that actually comes to your attention and you actually see. Another one, like for instance, outlier. I have not discussed about outlier. That is another issue. You'll find it in your quiz. Now, statistics, statistics. Now you can see the overall statistical information. You can plot the bar plot and see. So TCP, UDP, okay. You can see the distribution. You can know these things. Did you know? Achha. Correlation analysis is something we want to do. Okay. Again, the correlation analysis, and this is your heat map now. And you see some in the middle two features, there is no values are there, right? It's completely white. So there can be something wrong with that. Achha. Also, you can see if we look at like between two features, not the target, there is something completely white. White means it is close to 1. এখন আসি এখানে after duplicate rows, highly correlated features, মানে internally correlated, not with the target variable. So let's say your feature 1, feature 2, their internal correlation is 96%. What does it mean? It means what internal correlation, it means what this feature represent and what this feature represent is almost the same thing, right? 96% correlation. বোঝাচ্ছে আমার কথা?
Yes, sir.
So in such a scenario, one feature is enough for you to actually represent the data. Okay, you don't need two features. When you have this kind of highly correlated feature, you want to keep one of them and you want to remove other one. বোঝা যাচ্ছে আমার কথা? So this is called redundant features. Alhamdulillah, or duplicate features. So this is another thing that you want to remove. If you have like this kind of redundant information, two features representing the same thing, you want to remove that one feature. Okay, so that is what you can actually get from this correlation. Alhamdulillah. From this correlation analysis. Acha. Also in the middle, we can see there are two features, num, outbound, CMD, something are different. Acha. So
স্যার
first, হ্যাঁ বলো।
স্যার 10:40 বাজে।
হ্যাঁ আমরা অলমোস্ট 5 মিনিটের মধ্যে হয়ে যাবে। So there are two features in the middle why this is white. So you can ask this question, why this is white? So if you look at the value counts of this one, you can see 145,000. That is the original number of data. And that many features are, that many rows are actually have the same values. So that means this is a constant values feature. Just like previously, this is called constant valued feature. That's why you want to take the class in the afternoon. I don't have it. I hope. Constant value feature means sometimes it can happen that all the values are unique. Okay. So if all the values are unique, then it does not actually, unique means constant, it is not changing. So if the value is not changing, then it does not actually have any relation with the target. So if you have any constant values features, you want to remove it. Okay. So whenever you get some constant values feature, you can remove it. So we have found two constant values features, so that's why these two are removed. Then remove features. So redundant features, just like I said, you set a threshold correlation value 0.9. You can make it 0.95 based on the number of features we have available. So you remove the features that are too high. So you can see there is a stack function. Now you can say these are the relation, number of compromised and number of root. They have the relation 0.99. That means these two actually represents the same thing. So we can actually keep one and remove the other one. Okay, this way you can actually define which features you should keep and which feature you should remove. And this is what you have. So this way I actually remove some of the features. So after removing the features, now we have 32 columns. Okay, reduced. Originally it was 42 columns. I managed to remove 32 columns from there. Now, map categorical features. Now, you have seen 0, 1, 2. That's fine. You can easily map 0, 1, 2. But when you have too many categories, for instance, here in the flag feature, there are almost 10 categories are there. Then using map, you have to write for each of the categories 0, 1, 2, 3, 4, 5, 6, 7. This becomes very much difficult for you. Okay, too much task. So there is easier way to do it. That is called label encoding. Okay, in the scikit-learn library, there is a function called label encoder. It is going to automatically transform the categorical features from 0 to 1, 0 to 10. 0, whatever the number of categories, it will just transform it into 0 and 1. And it works the same way, just like before. You create an object label encoder, then you fit transform your data. So that when you fit transform your data, all the values are now automatically transform into 0 and 1 and 2. You don't have to write it in a map. So this is one thing that you did not learn before. So this is label encoder. Okay. So this is like a alternative to map. If you have like 0 and 1 category, 2 category, then you can use map very easily. Otherwise, you should go for label encoder. There is another thing that is called one-hot encoding. Okay. So it creates one-hot vectors. So for now, you ignore this part. You don't have to do it one-hot encoding. It is better to do it label encoder for now. Okay. Acha. So one-hot encoding galo. Now you see for this one, for the surface, there are too many variables, almost 50, I think, 40 or 50. So for these things, if you try to do it, map it one by one, that would become very difficult. So after doing all this processing, now we can see the data is now, the correlation matrix, the heat map is now much more organized. You can see it is much more clear. We don't have any missing values, none values. So it is now ready. Okay. So this is now, you can say my data set is now ready now. Now it is ready for pre-processing. Okay. I have not performed any data analysis here. I just prepared my data set for your predictive modeling. So this is for your EDA part. Okay. Sometimes your EDA part is to process your data, make sure it is ready for your predictive modeling. So you have to remove all the missing values, remove all the redundant features, all this thing, blah, blah, blah. Label encoding, make it everything numerical, then make sure your data is ready. So when you try to go for some predictive modeling task, we'll see in the next lab. The first thing is you perform this part. Okay, whatever data you work on it, perform this part and make sure you note it very clearly. Okay. আচ্ছা শেষ এনি কোশ্চেন কার কোনো কোশ্চেন নো কোশ্চেন আচ্ছা আমি অ্যাটেন্ডেন্সটা নেই
Sleep.
ইয়া বলো এনি কোশ্চেন on 56
Yes.
I cannot ask I cannot understand what you're saying আচ্ছা
No. I'm not joking.
আচ্ছা ঠিক আছে okay let's see which sections are doing class today A2 B2 C2 right
Yes, sir.
Yes, sir.
আচ্ছা A2 কয় তারিখ 18 10 18 okay everyone from A2 only from A2 please write your ID just from A2 not the other ones it creates a lot of difficulty I am going to save it here directly 144 নিজেরটাই লেখো মানুষেরটা লিখো না 108 106 114 anyone else from A2 138 140 138 140
A2 156.
122 132 146 134 112 134 102 and not from C2 তো লিখতে বলি নাই 118 নাকি সাউন্ড বন্ধ করে দিয়ে বসে দেখতেছে মজা 152 I have not asked to write any other section why are you writing other ones mute করে রেখে এরকম করলে হবে
Did you take note 156?
yeah 156 okay
Yes, it.
anyone else from section A2 Okay. Now write from B2. Everyone from B2, now write your ID. Two 62. Two 24. 206. 246. 262. 222. Anyone is from B2? B2 টা বৃহস্পতিবার ক্লাস করলে পারতো। The B2 section should have take the class on the Thursday. So they were not here. Okay, now from C2. Three 302, 332, 316, 332, 310, 334, 302, 304, 330,